Hi guys, welcome to the next lesson in the quadratic polynomial series. We're looking at the discriminant today. If you haven't looked at the previous lesson, the roots of the quadratic equation, please do so because this will make a bit more sense as this runs directly from that. To begin with, what we might do, just to recap our last lesson, is look at sketching the graph of f of x is equal to, let's say, x squared plus x minus, actually we'll do plus 5, okay, where we need to label the x and y intercept. Well, obviously the y intercept is going to be that plus 5, so when I'm sort of sketching it, that part of it's going to be nice and easy. So that's plus 5 there. But obviously we need to figure out what the x values are going to be. So I'll look at this question and say, okay, well, if I looked at this as a product and sum question, where I'm looking for two numbers that multiply together to give 5, but add to give 1, that's not going to work out because 5 times 1 is 5, and 5 and 1 can't make that 1 there. So this becomes a question where we need to look at our quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Let's start to simplify it a little bit. Okay, negative 1 plus or minus the square root. Well, 1 squared is 1 minus 20. That gives me negative 19 all over 2. Now, that causes a bit of a problem because if I wanted to put that to 1 or 2 decimal places, you'll notice that your calculator comes up with a math error. No, you haven't done it wrong, but what the problem is this part. We can't have a square root of a negative number. It doesn't work. We spoke about that last lesson saying that therefore, because it's a negative square root, there are no solutions. And I spoke about that square root part, that I guess if we're looking at the quadratic equation, it's that b squared minus 4ac, which is the bit underneath the square root, is really, really important because when it's a negative, which means, my apologies, when it's a negative, you can see that it shows that it has no solutions. Now, that doesn't mean that there is no parabola. It just means that there are no x values on the x-axis, which means that my parabola is going to not cut the x-axis, so it's going to be above the x-axis. Now, obviously, if I looked at this sketching part of it, I'm not sure which side it goes, so I'm going to chuck in the value of, let's say, 1 and see what happens there. So 1 squared is 1, plus 1 times 1 is 1, plus 5. So 1 plus 1 is 2, plus 5 is 7, which means it will be up here somewhere, which means that my parabola will look something like this. Okay, something like that. Now, I'm only sketching it, I'm not graphing it, so it means I haven't bothered to find out what my axis symmetry would be. Remember, I'd be forced to use the equation negative b over 2a in order to find that. Then if I find my turning point, I'd sub it back into the equation. But in this case, I'm just asked to sketch it, so I'm just looking for any x or y intercepts. So the whole point of this lesson is looking at the discriminant. So what is the discriminant? Well, we call the discriminant delta, and we refer to it as delta equals b squared minus 4ac. So the discriminant is that bit underneath that square root sign, okay, when we're looking at the formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Because we said that in that example there, that b squared minus 4ac, if that is less than 0, so that's a negative number, we automatically have no real roots or no solutions because it means it can't cut that x-axis. It doesn't work out because we can't find the square root of a negative number. So we said, and we mentioned that last lesson, that if delta is less than 0, which means that this bit here is a negative number, we have no real roots. Sometimes they're referred to as imaginary. Okay, there are no real roots. It doesn't cut that x-axis. It doesn't mean that the parabola doesn't exist. It just means that it's completely above. Now, referring back to that last lesson, can you remember what that would be called? That would be called a positive definite, because it's definitely above the x-axis, and it's a positive graph. Okay. All right, so you can clearly see that when we have a negative value for our discriminant, then there are no real roots. There are other cases that happen. I said we did this last lesson where we know that there are three situations that can happen. We can have, obviously, the no real roots. Okay, which means we have no real roots when I have my parabola. It means it's going to be either completely above the x-axis or completely below the x-axis. No real roots means there are no x-intercepts. We said that there could be one root, or we can call it equal roots. And that occurs, obviously, when it simply just touches that x-axis on either side, whether it be a positive or negative line, which means, obviously, if it only touches it, it means there is only one x-intercept or one x-intercept. So when might that happen? Okay, well, thinking about my formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, when I've got one real root, one only, it basically means when I do my number plus my square root sign over 2a, or I do my number minus the square root sign, it needs to be the same answer. The only way that can happen, and I'll show you an example here, we might have something that looks like this, like negative 4 plus or minus the square root all over, let's say, 2. In order for this not to change, the only way that can happen is if I'm adding nothing. Because what that lets me have is, for example, negative 4 plus 0 all over 2, or negative 4 minus 0 all over 2. Okay, if that's a number, for example, 1, then obviously minus 4 plus 1 is minus 3, minus 4 minus 1 is minus 5. They're going to be different. But in order for this to have the exact same answer, that part there must be 0 both times. So what that means is, in reality, it means that my delta, my discriminant, b squared minus 4ac, must equal 0 when we have one equal root. Okay, one root or equal roots. Okay, so for no real roots, we know delta is less than 0. When we have one root, we can set delta has to equal 0. So what do you reckon is going to happen for two roots? Well, hopefully you might think that delta will obviously be greater than 0. For example, if we've got negative, let's say negative 4 plus or minus the square root, let's say we've got 25 all over 2a, which is to say 2. Again, I'll just plug those numbers from absolutely nowhere, so don't worry about that. But you can see here, when I'm doing my answer, I'm going to get something like this. Negative 4 plus 5 over 2, or I'm going to get negative 4 minus 5 over 2, which gives me two different roots. Two different roots. So when the delta or my discriminant is greater than 0, we have two roots. Obviously, they have to be unequal roots, because if they were equal, then we'd only really have one root. Okay, so often they can be called as two unequal roots. So just to recap, when we're looking at my discriminant, okay, which equals b squared minus 4ac, I'm going to put brackets there, the discriminant. Why do you think it might be called the discriminant? Okay, well, it discriminates between the three different situations. It discriminates between, for delta is greater than 0, we know we have two roots. I'm going to put unequal there, because they have to be different. When delta equals 0, we have one root, or they can be called equal roots. And when delta is less than 0, we have no real roots. Okay, and again, what does that actually mean? Well, for each of these three things, I'm just going to draw a little parabola. If I've got two roots, it means it cuts the x-axis in two different places. If I've got one root, it means it hits the x-axis one spot, and no real roots means it sits directly above or possibly directly below. Remembering that these two here we spoke about last lesson, that we call positive definite. That would be called negative definite. And this one would be called indefinite. Okay, and it can be positive or it can be negative, hitting two spots. So that's what my discriminant is. Okay, it's my discriminant. So how does it help us? I mean, look, we can be asked to prove that that there are no real roots. And so what you're trying to show, if there are no real roots, you're trying to show that delta is less than 0. So instead of having to find out the total part of your quadratic equation, negative b plus or minus the square root of b squared minus 4ac all over 2a, which we have done in the past, if you can simply show that b squared minus 4ac is less than 0, then you automatically show that it has no real roots. Okay? It might ask to show that it's got two unequal roots. In that case, we want our b squared minus 4ac to be greater than 0. And if we can show that it's greater than 0, then we're pretty much there. They do get more challenging, however. Okay, I will say that. So look, I know we're going over the time here, over 11 minutes, but I just want to show you two slight questions that they can possibly ask. Okay, so for example, an easier question to start off with might be x squared minus 9x plus 20 equals 0, and it might say show if it has either, sorry, I can't really read that too well, either 2 roots, 1 root, or no real roots. They might also say equal roots, unequal roots, etc. So for this part, you could do the whole quadratic formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. However, now the fact we know that the discriminant is called b squared minus 4ac, all I need to figure out is what this discriminant is going to be equal to, and then I can say that it's either going to be greater than 0, 2 roots, less than 0, no real roots, or equal to 0, obviously it's going to be 1 root. So let's do it. Now remember, this is in the form of ax squared bx plus c. So in this case, my a is equal to 1, my b equals negative 9, my c equals 20. So I'm going to put delta equals, well, b squared, well, negative 9 squared, 9 nines are 81, it's going to be a positive number, minus 4 times a times c. Okay, well, 4 times 20 is 80, so I'm going to get 81 take away 80, which equals 1. Therefore, delta is greater than 0. Therefore, we have 2 unequal roots. What you will find too is that they might ask you as an add-on question, are the roots rational or are they irrational? Which is not a bad thing to talk about now, because these are actually irrational. What does that mean? I guess, well, it means when you put it into that quadratic formula, you know, are you going to have a surd there, like an ugly surd, for example, the square root of 3, which is not going to be a whole number, as opposed to the square root of 4, which would be 2, which is a nice whole number. You know, that's quite important. So basically, if you want to know if it's a rational number, if it's a perfect square, that means you can square root it, like square root of 4 equals 2, then it's going to be rational. If it's not a perfect square, for example, root 3, where if I square root 3, I get like a really ugly number, then it's going to be an irrational number. This case, because our answer is 1, square root of 1 is 1, we could call this being a rational number or a rational root. Just a little bit of an add-on they can ask you. So that's pretty straightforward. You're simply showing you, stating what b squared minus 4ac is, and then stating if it's either greater than 0, we have 2 roots. If it's equaling 0, we've got 1 root. But obviously in this case, if it's less than 0, we've got no roots or no real roots. But in this case, we have shown that there are 2 unequal roots as it's greater than 0. Okay, that's the first style of question, very basic style of question. Okay, so we come to the difficult question. and you will find this difficult most likely, and you'll need to certainly go through a few of these. For those of you in my 2-unit class, I'll just say that this is going through exercise 9.4 on page 360. But for this, I'm going to look at a question which states, let's say, find values of P if Px squared minus 2x plus 3p equals 0 has no real roots. Now they can often ask you, say that, can you find the value of P when it has 2 roots, 1 root, or no real roots? So you think, well, what am I supposed to do here? Because obviously I've got these P's here, which is going to make life a little bit challenging. So what do I know about the question? Well, it talks about having no real roots. When I think no real roots, I think this. Delta is less than 0. Because if it's got no real roots, it means when I put it into my b squared minus 4ac, it's going to need to have a negative value, which means that there are no solutions. So we know that delta is equal to b squared minus 4ac. Once again, I'm going to write that that is called the discriminant. So what we need to show, basically, that is that delta is less than 0. So what I'm going to do, I'm going to substitute my numbers into b squared minus 4ac. Obviously, it's going to be more challenging because in this case, my b is negative 2. Well, negative 2 squared is positive 4 minus 4 times a. Now, a this time is p times c, okay, which happens to be 3p. And we're going to show that this is less than 0. Okay, I'm just going to try to move this screen up. Hopefully this works. Okay, so let's simplify this a little bit. Well, 4 times p times 3p. Well, 4 times 3 is 12. So I'm going to do 4 minus 12. P times p is p squared is less than 0. Now this comes back into, I think it was a second lesson, where we were looking at quadratic inequalities. And obviously, hence why we went through quadratic inequalities earlier on. So what we need to show is we need to solve this, okay, which we can do certainly different ways. Okay, now my apologies, I've probably jumped to quite a challenging question, but we're going to solve this as we would, I guess, an inequality. I'm going to add the 12p squared over here. So I'm going to get 4 is less than 12p squared. I'm going to get rid of the divide by 12, and I'm going to have 4 over 12, which is what's going to be 2 over 6, is less than p squared. Okay, so what I need to do to finalize that, I need to find what p is. That's what the question's asked me. So I'm actually nearly there. I'm actually nearly finished. But obviously I need to square root both sides. So I get p, make sure that's the bigger bit there. And then I've got the square root of 2 over the square root of 6. Remembering that when I square root something, we get a positive or negative value. So let's rationalize that. We always want to rationalize, remember. So p is greater than, remember it's positive or negative. I'm going to times, I'll do it in different colors so you can see them both by root 6 over root 6. Always rationalize. So I get root 12 over 6. That can then simplify. P plus, p is greater than, plus or minus. It's going to be 2 root 3 over 6. So p is greater than, plus or minus. It's going to be root 3 over 3. Now, in this case, remember there are two possibilities things of happening. We can have, because it's got no real roots, it can be positive definite, so it can be up here somewhere, or it could be negative definite. Okay, so because you've got this plus and minus value, there are actually two different possible scenarios that you could have for p. P could be positive root 3 over 3, which I'm guessing would be that one, or it could be negative root 3 over 3, which would probably be that one there. Okay, like quite a challenging question, and obviously I've gone over 20 minutes. I want to stop there. I don't want to keep on doing some more questions. What I might do a separate video and just have some worked answers from that particular exercise. It is quite difficult, but I guess for when you're doing these steps, the things that you should be looking for, if it says it's got no real roots, I'll just try to go back to the slide that I looked on that had those there. Let me just bear with me. Okay, if it says that the equation has no real roots, then what you'll be looking at is, my apologies, that delta is less than 0. So when you're putting in, find out what b squared minus 4ac is and put less than 0 and solve it. If it's equaling 0, obviously it's just going to be equal 0. If it's 2 roots, then obviously you put it as greater than 0. And each time solve it, and then you can work it out from there. Okay, look, it is a bit more challenging. It's certainly something that's a little bit different. So please make sure you do lots and lots of these questions and practice them, because certainly the discriminant is one that comes up in the HSC. It comes up in the preliminary exam all the time. It's something that you really need to know a fair bit about. So again, that's exercise 9.4 on pages 360 to 361. Give it a crack. If you want some more work, please let me know. I hope this wasn't too confusing for you. If it was, let me know and I'll try to redo the lesson. Cheers, guys.